So that first one was, I believe, juice.
Even greater rooting in bio and juice combined. This is just all roots, great structure, a lot of bugs.
Look at that. Ecosystem in a bottle.
Yep.
Not the ecology.
And just, I think I show the weights on this one. Here we go.
Juice combined with biology, 2.7 ounces, and
that was wet weight.
all stay together.
Look at that.
Just
Is that not incredible, Av? That was crappy soil.
Wow. Did you do a taste test?
Did I do a what test?
A taste test, a little sensory evaluation. Was it any spicier or?
No, I actually didn't. I sent off all of the plant material for plant nutrition, which we can bring up next.
Okay.
Again, I didn't get all the data because it was a cold. Let me shut up.
One as the combination, but again, just great rooting structure and pretty darn good soil structure.
So, to answer the question,
2.1.
yeah, I should really talk about the wet weights. So 2.1 biology only, 2.4 juice only, 2.7 combined, and it was like 1.5 in control. So unfortunately, the weather out here was just horrible for this experiment. We had cold weather, tremendous amount of rain. Those plants were almost drowned about 4 or 5 times.
Yeah.
No sunlight. And I had to let them go to seed just to get enough biomass to send out for the test. So I went past the nutritional value of the material. So we get some really kind of interesting information. And Gary, maybe you can speak a little bit about this in fiber versus protein versus digestibility. And all of those factors we did get results on. But again, it was unfortunately already seeding or past flower into seed. So we lost the most important part of it. And again, that was a preliminary experiment. We're definitely going to repeat that one. We are a lot of them, just to, again, to validate, verify, and qualify and quantify that these results are in fact going to happen over and over again. And I don't know if anybody wanted to add anything. Otherwise, why don't you pull up those reports from the A&L lab, Ken, and we'll breeze through those real quick.
Yeah, those are interesting.
I know we buried him. He's struggling to find it out. No, that's Andy. It would have been that one that I said no that you pulled up earlier.
And no, as Ken's digging that up, or Gary, in terms of if you had an incredibly fibrous feedstock, is it just take a lot longer to get the juice that you want?
It does take a little longer to break that down, yes. So what we typically like to do when you have your more fibrous material is feed in a smaller amount of it, because then it does digest well. And sometimes we have to recycle it through depending what we're running, wood chips, various things like that, for example, as well. Your softer waste is much easier to process, and again, this also just comes back to that diverse mixture that I was talking about before. If you went to just process your highly fibrous material, we would have to change the process. We'd have to run it longer. If you mix it, then it tends to go well.
Yeah, but like you know, if you follow Elaine's discussions around ecological succession, and you've got a plant that has a 1-to-1 fungal to bacterial ratio, are you also trying to put your feedstock in at a particular ratio to get that type of muncher juice? Does that make sense?
Yeah. And I haven't run it specifically that way.
Yep.
So that would be something we'd have to run to see, which when we get our benchtop unit will be very convenient to do.
Yeah, again, we've got a lot of work left to do in both formulation and understanding more about some of these unseen forces that are occurring.
Yeah.
Not just the inoculant, the bioinoculant, and not just the actual precipitation of raw organic nutrients out of it in their raw form, but also like Mo mentioned is these ions. You know, ions are plant available. So, you know, who knew? It's beyond an exudate.